Hi everyone, let's solve today's daily challenge, that is intersection of two arrays. Now in this question, you're simply given two integer arrays, nums1 and nums2, here you can see, and you need to return an array of their intersection. Now what is intersection? Intersection basically means if you're given two entities, like you must have remember how you used to study, like you are given sets and then you have to find the intersection. What is the intersection part? This part, right? The colored part, this is called intersection. Now if I may draw it for both these arrays, what will I get? Let's say my first bubble represents the array elements in nums1, right? So I can place them like this, 4, 9 and 5, right? And here I'm going to consider the unique elements. So here the unique elements are 9, 4 and 8. Okay, so because in the question it's mentioned that in the result every element must be unique, right? All right, so 9, 4, 8 are the unique elements in nums2. So I can see that 8 has to be here, and this is the second bubble. It represents your nums1 array, nums of 2 array, and you can see the intersection part is 4 comma 9 or 9 comma 4, because you can return your answer in any order. So this is what you have to do in this question, return the intersection of both the arrays. All right, now how to solve this question, right? So the very naive approach to solve this question would be to simply iterate in nums1, and for each and every element of nums1 iterate in nums2 also. So if I say, let's say the size of nums1 is n and the size of nums2 is m, so I have to apply two loops, that is I is equal to 0 to n you have to go, and for j is equal to 0 to m you have to go, and you have to, for each and every element, this is I, right? You have to iterate in whole of nums2 array and keep checking for the values. Now here let's do a dry run, right? So we have 4 ith element. Now I'll iterate in nums2. So j will be here, then j will be here. Okay, I find an element which is equal to 4. Both the elements are matching. So inside of, let's say, my answer array, I'll include this 4. Then I'll iterate j. Okay, again here I'm able to see 4, but it's mentioned in the question, the result, each element in the result must be unique, right? So this is not unique, you have already included it. So you have to also apply something called search, right? You have to also keep searching whether this element is already present in my answer or not. So 4 is already present, so I don't have to include it, right? I have to move on to the next element, right? So this is what you have to do. And let's say for search you apply binary search, right? So in that case, let us analyze the time complexity. First of all, for this part, your time complexity is going to be n into m, correct? That we know, right? Because we are iterating for in a nested for loop, right? Then we are also applying a binary search on what? The answer, right? So let's say in the worst case, what would happen is we can have all the elements of nums1 and nums2 like equal, right? So let's say nums1 is having 3 elements and all these 3 elements are present in nums2 also. So that means whatever is the minimum length of n and m, log of that, right? Binary search takes log of some elements number of time, right? So let's say if it's n, so log in time it will take, but here in the worst case it will be minimum of n comma m, right? So this is the time that you're going to take, n comma m. Now you can see this is a huge time complexity, and this will definitely give you TLE. So what is the other approach, right? Can we optimize it? Definitely. What we can do is, as we know, we need unique elements, right? So we can take a set. Okay, we can take a set, and using that set we can iterate here. But again, that is essentially taking rid of this, not necessarily, because you have to find that element inside of set also. But even then your time complexity is going to be the same, right? So both of your approaches are going to be giving you the same time complexity. Now what else we can do? So let's see. Now notice one thing, right? Here the order of the relative order of the elements is not compulsory or necessary to form an answer, right? All you have to do is take the intersecting elements, that is the elements common to both nums1 and nums2, right? So um, the previous day's challenge was also similar to this. There we had to find the first common element between nums1 and nums2, and there we were given sorted arrays. So if you can connect from there, or rather I'll explain you here only. See, the relative order of elements is not important. That means I can sort the arrays. Even if I sort the arrays, I am not going to like, I'm still going to get an answer. Okay, so that means my nums1 will become 4 5 9, and my nums2 will become what? 4 4 8 9 9. This is what both of these arrays become. We have to sort both the arrays. Now if you have not like watched the previous day's challenge solution, please go on to my channel, watch it. But let's go ahead with this. Like, it will be easier for you to understand this if you have already watched that solution. But anyways, let's go with this. Now both my arrays are sorted. Right now what I can do is I can get rid of this loop, right? So now what I can do is I can iterate nums1 and nums2 simultaneously. How? What I'll do is I'll take a pointer I here, I'll take a pointer j here, right? Both are at the first indexes of the arrays. Now what I'll do is I'll compare these elements. Are they equal? Alright, if they are equal, please include it in your answer. Alright, so let me take answer here. Okay, so answer is, we're going to include these elements if they are equal. 4. Alright, now how we have to move forward, because we are not having a for loop, anything like that. We're just iterating in both the arrays based on some conditions, right? So keep seeing. So we had I and j here. Now I've I have already included these elements, right? So I have to move both my pointers, right? I have to move both my pointers. So my j is here and my I is here. If my I is here and my j is here, now if any element is lesser, see, jth element is less than ith element. So that means if I want this jth element to match my ith element, right? Certainly these two are not matching, right? So I have to move my j pointer to the next element, because then my chances of matching the ith element, jth element will, like, it will be much closer, right? So we'll move j here, right? So notice the conditions. Whenever, see, the condition, first condition is if nums1 is equal nums2 of j, right? Nums2 of I. Then move both the pointers I plus plus, j plus plus. Else if both are not equal, then you have to check which one is lesser. Let's say if nums1 of I is less than nums2 of j, that means if you want, certainly I and j element are not matching, right? But if you want the I and j element to be matching, if you want their chance of having a match, then you have to move which pointer? Ith pointer, because you want to match to a greater value, right? So you'll move I pointer. Otherwise you have to move your j pointer, right? So that's what you're doing here. You moved your j pointer. Now again check the condition, j, this condition, right? I'm not considering unique elements at all right now. I'm not considering that. Okay, all right. So if they are matching, are they matching? No. But ith element is less than the jth element. Which element I have to move? Ith element, because j is greater, right? And they are not matching, so I have to have increase the chance of them matching. So I'll have to move the ith pointer. Now I pointer is here and j is here. Again match them, right? Again not matching. But which one is lesser? Jth pointer value is lesser, right? So we have to move the j pointer. All right. Now you can see that I and j have matched. If I and j have matched, then you have to include it in your answer. And now I is already obviously is going to go out of bounds, so you have to quit. All right, so I hope you've like understood how we are forming the answer. First you are sorting the array. Now the purpose of sorting the array is simply that, see, if my arrays were not sorted, how would I have decided what direction I have to move? But if my arrays are sorted, this algorithm using two pointer, right, it's so efficiently done or implemented, correct? So this is what you have to do. Now talking about, see, this is the first advantage. Let me write it here, right? What is the first advantage of sorting the arrays? First advantage of sorting the array is that, you know, after current element I'm going to have a larger value only, so direction decision, right, is easier to make, as current element is going to be less than or equal to the next element, right? Now, what is the second advantage? Let me show you the second advantage, and that advantage comes for checking the unique elements. See how now you don't have to apply any search or anything, right? So let's see. Now all you have to do is first check this condition, they are matching, all right. Do not do this right straight away, you have to do this, but first check before including your answer, right? First check if this value already is present. So how do you check it? Just check the last element of the array. Just check the last element of the array. So if you have to simply check if nums1 of I is equal. In C++ you have a function called ans.back. So back basically returns you the last value of the array, correct? So it returns you the last value. That means if it is already present, right, that means you don't have to include it in your answer. Now how is this effective? This is effective because you know that you have included this in your answer, right? Now the next value if you go to will definitely be greater or equal, right? So it can never be less. It can never be less. So it helps you to determine the unique element just by checking the last element of the array. So which takes O1 of time only, right? Because you have to check just the last element. So that is it. So this is the second advantage. You can keep track of the unique elements by simply checking the last element of array, which takes only O1 of time, constant time. So basically this operation is going to cost you constant time rather than of any search. Like if you are using binary search, login operations, if you are using linear search, that's even worse, linear time, right? Or n number of operations, correct? So these are the two advantage that you're going to have using this algorithm. Let's try it out for the first test case. The first test case is what? Nums1 is 1 2 2 1 and nums2 is 2 2. So let me write it here. Nums1 is 1 2 2 and 1, and nums of 2 is 2 and 2. So what is the first step? First step is sort the array, both the arrays, right? So if you sort nums1, what you will get? You will get 1 1 2 and 2. If you sort nums2, it is going to be 2 comma 2 only. Now start your algorithm. So what your algorithm is, you are iterating in your while loop while I is less than j, right? And what are the conditions? These are the condition, I hope you remember them, right? See, if they are the conditions, you are at I and j. Now check, are these elements matching? So if they are not matching, see, if they are matching, what you have to do, you have to check if it matches the last element of the answer or not, right? Okay, so I and j, they are not matching. So that means you have to move one pointer. Which pointer you are going to move? You are going to move that pointer which has lesser value, which is I in this case. So move I pointer. Now, are these matching? No, they are not matching. So again, ith pointer value is lesser. So move the ith pointer. So 2 are matching. Yes. So answer, include 2 in your answer. Now, move both your j pointer and I pointer. So you have incremented both. Now see, now you're going to see that the values at ith and jth point is still matching, but is this going to be a unique value if you include in your answer? No. So you have to check the last element. So last element is what? 2. So 2 is matching the current element. That means you don't have to include it. It's already included, right? So this is what the algorithm is. Now let us go ahead and quickly see the code. Then it will be more clear, right? So here we have first taken the answer and we are sorting both the arrays. After we sort both the arrays, we are taking 2 pointers, I and j. So I basically denotes the 0th index of nums1 and j denotes the 0th index of nums2 array. After that, I have also taken the sizes of both the arrays. So for the first array, the size is n, and for the second array, the size is m. Then we are checking while I is less than n and j is less than m. Then what you have to do, you have to compare the value of these, right? If they are matching, all right, but there is one condition. You have to check that whatever, if you have any elements present in your answer, right, the last element, if it is matching, you don't have to include that particular element in your answer, correct? So first also check that you should have any element inside of your array, right? If you have an element and that element is not matching to the current element. That means it's not present in the array, so include it. Otherwise, if you don't have any element, then also you have to include it, right? So these two conditions only you have to check, and move both the pointers. That you have to do, right? If they are matching, you have to move the both pointers. then then what you have to do, if they are not equal, if both the values are not equal, you have to check if nums of I is less than nums 2 of j, right? So what you are basically trying to do here, you're trying to basically match the values, right? So if this particular nums 1 of I, right, ith pointer's value is not matching jth pointer and it is lesser, so you have to move this pointer to increase your chance of matching the value, because obviously these two values are not matching, right? So if they are not matching, you have to match the value. So which pointer you will move? You will move the pointer with lesser value so that you can match it with the larger value, right? So there is a chance. So move this, otherwise move jth pointer. And after this, what will happen is you will be forming an answer with only unique elements which are intersecting or common in both arrays, and simply return that. So I hope you have understood what we are doing, what is the approach and how we are coding it. Now let us look ahead to the time complexity and space complexity of the solution. So the time complexity you can already see is you are simply iterating in both the arrays simultaneously. So it's going to be big O of n plus m. Now, for this answer of back, you are not doing anything. It's constant operation. So your overall time complexity is big O of n plus m. So this is your time complexity. What's your space complexity? It's constant because you are only using um, I and j pointers. All right, time complexity is also going to be because of sorting the arrays. If you are already given sorted arrays, it will be this, but plus it will be m log m plus n log n. So your overall time complexity is, you can say maximum of m and n, whichever is, and log of maximum of that value. So this is your overall time complexity and overall space complexity, that is constant space. So I hope you have understood how to solve this question.